Hello and welcome to this tutorial on how to do concurrency with channels in Rust. So this is our project. This time we won't be adding any dependency on our cargo.toml file because we're gonna use only code from the standard library. So if we go ahead and check our main.rs file, here you can see some documentation about what we're going to do. Basically, this is from the standard Rust website. You can check about channels, threads, and this module we're gonna use later. So let's check what we're going to implement. We're gonna define a structure to represent some arbitrary work we want to do. Basically, this is a very dummy structure that tells how long we need to sleep in order to pretend we did some work. And then some context about how many messages we're gonna send to our channel, how many threads we're gonna spawn, stuff like that. Then we're going to set up a channel to send and receive messages, and this comes from this module from the standard library. Then we're going to define a function to generate and publish some work to do. And so we're going to iterate through a number of messages we want to produce, and then we're going to produce these messages that create an instance of this structure and publish that to our channel. And then we're going to send these messages through our channel. Then we're going to define a function to consume these messages and with some details about how long it has to sleep to pretend we did some work. And then we're going to consume these messages in separate threads via a for loop. And eventually we're going to join all these threads to make sure they're all finished eventually. So let's get started and start by importing some modules from the standard library. Here the most important thing is this module that is about a multi-producer single consumer queue. And this is the way you define channels in Rust. So let's define this structure we're gonna use as a message. So every time we create an instance of this structure, we send that as a message. So we have an ID, so we can pretend to assign an increasing ID number to each instance and track and monitor how many threads we create and how many threads we join. Then we have this field that basically dictates the thread to sleep for a given amount of time. And then we have this down field that we set to true only after the thread slept for this amount of time. All right. What else we need to define? Some context about this word. So these are implementation details and they're not necessary for an arbitrary code we want to run for channels, but that's for clarity. We define the maximum amount of work products we're going to define. Basically, we're going to send 5 messages to this channel with 5 instances of this structure. And because Rust is very efficient when it creates new threads to consume these messages, it does that instantly. We want to add some arbitrary delay in between new threads that are created to consume a new message each thread. So we slow down a bit the execution of the code. And also we're going to check later that given that we generate some sort of pseudo-random amount of time we want to sleep for each thread, and we store that in each message that we send. Given that we're not using any external library to do this, basically we adding some sort of delay in between new messages that are generated helps, because we create numbers that represent a random amount of time to sleep that look a bit more random, and we're sure we can see a bit more of volatility in the way threads sleep and then join back the main thread. All right, so let's go back to our plan. We defined a structure, we defined some context, and now we can set up our channel. So let's go ahead and do this. Okay, as you can see, we use this module from the standard library to generate a new channel that creates a sender and a receiver, and they are used generics, and the generic is our dummy work structure. So basically here we're saying this channel is dedicated to send and receive objects, well, instances of type dummy work, and we define this as a structure above in the code. Okay, so now we need to define a function to generate and publish this dummy work in our channel, our TX side of the channel, which is where we send messages. So in order to do this, let's see a bit of structure in this main file. Okay, so remember we defined this max work products. Here we're gonna iterate through the numbers between 1 and 5, and for each number we clone the sender channel, and we're gonna send it to the publish dummy work. This is not involving threads, and we're gonna see how it is implemented later. After we publish a message, before going into the next iteration, we sleep with that amount that we set before, and this is about assuring that numbers of all these dummy work structures are a bit more like volatile, and so we see different amounts of milliseconds that require the consumer to sleep, and everything seems a bit more realistic, let's say. So let's go ahead and see how is this function publish dummy work written. What's the content of this function? So let's go here. All right, here you can see we generate a new instance of this dummy work, and then we clone this instance and publish that via the sender channel that is injected into the function when invoked. Now, what is this get pseudo round number? This is all about trying to avoid to import dependencies to basically do the work for us and stick to the standard library. But this is a very, let's say, simple function that is defined like this. So basically we take the current timestamp as an epoch, and then we basically take the reminder of dividing this epoch by 10, so we get some sort of number between 0 and 9, and then we multiply that by 1000, and we give back this as milliseconds, and that's the amount of time we're gonna sleep in our consumer. And basically the range is 0 and 9999 as the maximum amount of time a thread could sleep when consuming a message. All right, so we define the function that is publishing messages to this sender channel. And this function is generating at runtime a given amount of time to sleep in milliseconds for the current message. So the consumer later will sleep depending on this runtime evaluation. And this runtime value comes from basically the timestamp of the clock for the computer. And there's a bit of math involved to generate a realistic number of milliseconds to sleep. All right, let's go back to our main function. So we define this channel with sender and receiver. We defined a way to publish messages into our channel, and then we need to send these messages to our channel. So yeah, actually we already did this. Apologies. So this is about sending these messages. Yeah, we actually did it here. So we're publishing messages to this channel. Okay, so let's define a function to consume messages representing this work that needs to be done. And as we've seen before, this is about basically making our thread sleep for the time specified in our instance for the dummy work. So let's make some space here. And here you can see how we consume work. So we have an ID that represents this thread, and we basically do thread sleep coming from the sleep millis from the dummy work. And the dummy work is defined like this. So we have a field that dictates how long the thread should sleep. And then when we slept, we set the down field to true and we return. Okay, so let's go back to our main function, and here we can introduce some code that allows us to consume messages. All right, so let's go through this code. So this is an iterator coming from the channel that we are defined here. So the receiver channel can constantly produce new messages according to the fact that something has published these messages. So we keep looping until we have messages to consume, and we take a note of how many messages we have consumed so far. And here we see that basically we are spawning a new thread with a closure that just invokes this consume dummy function with the current message counter and the dummy work we want to perform. And this dummy work comes as an instance of the dummy work structure that has been sent via our channel by our producers here with publish dummy work. So given that we know how many messages we're going to send to this channel, this is just some code to break the infinite loop coming from this iterator when we know we already consumed all the messages that we were supposed to consume. So basically once we reach max work, given that we start from 1 to max work, then we know we consumed all the messages that have been published. So we break this loop and we go on with the calculations, but with the code. Now, we published all our messages to our channel. Then we consumed all our messages via threads that have been spawned. And now we just need our main thread coming from the main.rs file to join all the threads that have been spawned while consuming these messages. So we can do this with another for loop. And here basically we take all these handlers that we defined here. So we have a vector of handlers and we push all the handlers that come from a thread that has been spawned. And the more threads that we join, the more handlers we consume, and eventually we consume all the handlers. All the handlers have been joined, and so our main thread is done, and we can basically stop the execution of our program because we're done with all the messages. All the messages have been produced and all the messages have been consumed. So to recap, we defined a channel with send and receive. We produced some work and published these messages to our channel. And then we consumed these messages with threads. So each message is consumed in their own thread. And then eventually we make our main thread coming from our main function, wait for all the other threads to join. So that means we successfully consumed all the messages. And so we can let our program finish because there are no other threads out there consuming messages. All right, let's go ahead and run this program to see if it works. So cargo run. Okay, so let's recap what happened. We published 5 messages, and then our main thread spawned new threads for each message that was being consumed. And then each thread has an ID, so worker 1 to 5, and he's performing some work, which is basically a thread sleep with the given amount of milliseconds. These milliseconds have been generated at runtime based on the epoch of our clock. And eventually all the workers are done with sleeping, so they can join the main thread. And once all the threads have joined the main thread is done, and we can end our program. All right, so here, as you've seen in this code, we've been dealing with channels, and channels are a modern way to deal with concurrency in Rust, but also in other languages like Go, for example. And there's this quote from Rob Pike from the Go programming language that tries to summarize why we use channels rather than mutex or shared resources to synchronize and orchestrate different threads. And this quote goes with, don't communicate by sharing memory, but share memory by communicating. So in this tutorial, we've seen an alternative way of dealing with concurrency, and this alternative way is by using channels to send and receive messages between threads. This is alternative to more traditional ways of doing concurrency with shared resources and mutex and stuff like that. Hope you enjoyed this tutorial. Happy Rust coding to everyone, and I will catch you on the next one.